All right, let's see how we did. How we're doing. All right, number one. A couple ways you can do it, right? You can either just subtract right off the bat. How many subtracted and just went from there? How many switched them around and then look at it? Okay, so I kind of like to switch them first and then subtract, just personal preference. Because then you get 3/2 minus 1/2, right? Which is 1. So you get x to the first, so x. If you subtract right off the bat, you get -1/2 minus -3/2. Plus plus, you get 1. So you still get x to the first, however you want to do it. Number 2, I would add these first. So that's -2 power on the top and -2 power on the bottom. Well, what's something over itself? 1. Number 3, you're just squaring everything. So 1 squared is 1. X squared is 4. X to the 4th. Number 4, power 1 here minus 1/2 would be positive 1/2 power. So a to the 1/2. And then here you can either subtract 3 minus -4 to get 7, or just bring that up, and that would be b cubed, b to the 4th, so b to the 7th. And then power to power, what do we do with these two?
Multiply.
So a to the -3/2, which is 1 over a to the 3/2. How did you do?
Pretty good. Wait a second, why is it 1 over just, why isn't it negative?
So we want to rewrite them with positive exponents only.
Oh,
So we're just rewriting that as 1 over.
but how can you just take the negative away like that?
That's the definition of negative exponent.
You can?
Yes.
It works?
Yes.
Oh,
X to the -n, Paul, is 1 over x to the n. That's
but I didn't see the 1 over, that's why. I didn't see the 1 over, so I was like, what?
get out your 3.3 notes. Okay, listen up. There's a reason I handed both out today, even though it says you're supposed to do 3, 4 tomorrow. So in this class, I have to go to a meeting. So if we have time, we're going to start those. Okay? If we don't have time, I'm going to post them on my website, and you're going to bring your laptop and get them tomorrow, right? You with me? It's stuff you did in algebra too, so it's not awful. All right. So let's see what we can get done today. 3. All right, are we ready to start logarithms? This is a great segue from our warm-up, because if you look at, oh man, I didn't pull it up yet.
I'm sorry.
Okay, ready? Okay, this volume's not going to be good. Okay, logarithms are, I'm going to leave you hanging for a second. Do you remember, what is it doing?
Yeah, how to rewrite it.
Whatever. Down here. Yeah, how to rewrite it, right? You have log base b of y equals x. Right? This. Where did I put it? Thank you. Okay. So this equals x, right? And see when you rewrite it, you get b to the x equals y. Do you remember that? Isn't x, what would you call x in terms of that equation? The exponent. So, and wasn't this equal to x? The logarithm was equal to x? So logarithms are exponents. They're just a way to represent what exponent you raise the base to get that number. Okay? So maybe you thought about it like that, maybe not. 2 logs that our calculators use, that are programmed to be. The LOG button is programmed to be base 10. So if you see a log without a base, that's understood to be 10. If you see a natural log, that's understood to be base E. Okay? So we're not using our calculator until I tell you to, okay? All right. Here we're just practicing going from one form to the other. We'll do the first one together. This one, the base is 2. Exponent is 3. That equals 8. Now I always tell people to check. Is that a true statement?
Yeah.
Okay. 2 cubed is 8. All right, go ahead and do 2, 3, 4.
I think Mr. Earl said something about this. He did something.
Yeah, he did some funny paper thing around that.
Yeah, he did. He did.
What is must it must
It's change.
keep change or something?
No,
I don't know.
Whip it.
Oh yeah, whip it.
Yeah, whip it, yes.
All right. Bailey, what's number 2?
4 to the power.
No.
0.
Okay. Kendall, what's 3?
12 to the first is 12.
Good. And Marcia, 4?
2 to the negative second.
Perfect. All right. Now let's go the other way. Number 1 down here. The base is 3, right? Log base 3. Then what number goes next? 9. And logs equal exponents, right? So it equals the exponent. 2. All right, 2, 3, 4. Brooke, what'd you get for 2?
Log.
Okay, base 5.
5. Times 1/25 equals negative 2.
Okay, so when you say this, you're gonna say log base 5 of 1/25 equals negative 2. Okay? Josie, can you say the next one?
Log base 1/2 of 8.
Perfect. And Nick M 4?
Log base 4 of 1 equals 0.
Perfect. Okay. So when you get down to these, it says evaluate and run the calculator. So notice there's no answer, right? We need to know the equals. So a lot of you, I know, can do these in your head, but I do want to show you like the method in case you need to ever work one out. So if you need to work it out, call it something, call it X. And then you're going to say, you're going to rewrite it, 5 to the X equals 25. And then you just say, what 5 to what power gives me 25? 2. So X equals 2, so therefore that logarithm equals 2. So number 2, 3 to what power is 81?
4.
Good. right, go ahead and try 3 through 8. Give you a few minutes.
Oh, you had stuff to turn in. Yeah. Just a little bit about that. Oh, you have stuff to turn in.
Okay,
Why am I doing that?
there.
Just tell me what she wants.
What do you want this turned in?
By the way, did anybody else need to finish the M&M lab and have it done? I know. Or- Make sure you do if you didn't turn it in yet.
Yeah.
1/3 was so that's next one. Think about what flips it. All right, let's see. Tie number 3. Yeah, you tie. Good. So what's the base on that log, Kai? 10. So 10 squared is 100. Good. TJ, number 4?
I got 81.
Too big. So let's see. 1/3 to what power is 27?
-3.
Paul. I was working.
I thought you were, I'm sorry.
It's okay.
Sorry.
It's all right.
No, it's okay about it.
I thought it, I'm so sorry. I thought you.
Okay. Paul's right. Paul, can you explain?
Because like when you do 1/3 to -3, that's the same as doing 3 to the 3rd.
Yeah. So anytime you're going from a fraction to a whole number, you're gonna have to be negating that the exponent, right? Or vice versa, if you're going from a whole number to a fraction, you're gonna need a negative as well. So everybody understand, TJ and everybody? Okay. So -3. Paul, did you get the next one? Since you're excited about logs.
Yeah, on 5.
Yeah.
5 is just x equals 4.
Good. Did you do it? Did you show work or did you?
Yeah, I e to the x equals e to the 4th.
Nice. So who was stumped on this one? This is one that you should probably work out as of this moment. There's a shortcut in a minute that might help you. So like Paul said, if you set it equal to x, the base on this is e, right? So if you rewrite it, e to the x equals e to the 4, right? So therefore x has to equal 4. Isn't that nice? All right. Next one. Lauren, did you get the next one? 6?
I got x equals 0.
Good. Because 9 to the 0 is 1. All right, 7. Is anybody confident on 7? I'm gonna go, Abram, go ahead.
I said it's 1/2.
Good. What did you do?
The base of that is 10, so 10 to the, so I said equal to x, 10 to the x is the square root of 10, so it'd be 1/2.
Good. So if you remember from our exponents, right? the root is the same as the 1/2. So therefore that's 1/2. And then 8, and I'll let you do 8 since we talked about that earlier.
-3.
Yeah. So this 8 and 4 kind of go nicely because this is going from a whole number to a fraction. That's going from a fraction to a whole number, both of which are negative. Okay, any questions on those at all? Okay, so let me show you something. Just, you don't have to write this down, just look. Okay. Is your hand up or just show? Okay. Okay, so what if I give you this? Log base b of b to the x. So if you were going to try to work it out, you'd set it equal to something. Give me another variable that you like. So if I rewrite it then, b to the y equals, so x equals, so you want to slide please? Just go in Okay, so we got x equals y, right? So if we kind of omit that, log base b of b to the x equals y. Does it appear that there's like a shortcut going on there? What's the shortcut?
Your facial expression.
Just take the power, because what? What's the same in the log right there?
No.
This, the base, and so it appears there's a shortcut that you can just kind of like slash them, right? And you just get the x. Doesn't that seem like that's what's happening?
Wait, this is for number 5.
I'm just, don't even look at your notes. Just enjoy it. Just enjoy this moment. Okay. Now, what if I go the other way? What if I give you that, where you have b to the log base b of x? Ready? So you want to set it equal to y, yes? Okay, now, see over here it was a log and I rewrote it exponential? Now it's exponential and I want to rewrite it as a log. So tell me what to do here. Base
Of y equals.
that whole thing's the x one, right? Therefore, so doesn't it seem like up here we just slashed them too?
I suppose, yeah.
It seems that way, right?
Yes.
Okay. There's something more important at work here. What is the relationship? Stay with me, Nick.
Sorry.
What's this is so cool. Ready? Logs and exponentials are what of each other? Inverses. Now, do you remember way back when? Way back when, like chapter, I don't even know. It was 1 maybe, I think. Do you remember if you had F and F inverse and you compose them with each other, what came out of it? It was just X. Do you remember that?
Yeah.
So logs and exponentials are inverses?
Yeah.
So didn't I just plug an exponential into a log and get X?
Yeah.
And I just plugged the log into an exponential and I got X?
Yeah.
Not surprising because we knew that already technically.
This is my peak. It's lower my real space.
Isn't that so cool? So all that being said, if I give you this problem down here,
X.
because base and base, right? If I give you this problem, X. Now, uh-oh,
3. Or is it not?
hold the thought. Are they the same right now? We can get them to be the same because 125, rewrite it, is 5 cubed. Beautiful. Isn't that true?
Yes.
Now our exponent rules, now wait, what do we do with the 3 and the x? So isn't this log base 5 of 5 to the 3x? So your answer is?
3x.
So Paul, you were really close in saying 3. You with me?
Yeah.
Now, I don't like the way that one got typed. That should be e to the ln of pi, like pi should be up. Okay. So what's the base here? Answer?
Pi x.
Just pi.
Why no x? Because there are none.
There's no x's in the pi. All right, but without that long-winded explanation, you would not have appreciated that, right? Absolutely. Okay. Okay. Are we ready to graph? Ready or not? Oh no, we're not ready yet. Sorry. my bad. No, we're not ready. Okay. Log of -10. What do you think? Let's rewrite it. 10 to what power is -10? -1, so 10 to the negative first is -1? That's 1/10. Kendall says no solution, what do you think? Well, okay, if we do some weird stuff, we could do that, but no. We're not gonna be in that world. Yeah, because think about it, can you raise a number to a power and go below 0? Like our E, like, right? Okay. So this isn't gonna happen. What about log of 0? Can you raise 10 to a power and get 0? No, right? Because if you think about it, even if you put really negative numbers, it's gonna get really small. It's not gonna go. It's not going to equal 0. So what I want you to write down, log of a negative is no good. Log of 0 is no good. That's kind of gross, but all right, we'll come back to it. Green on green. Okay, so, and then looking at 1, 2, 3 down here.
Oh, sit down.
One of them you can automatically tell me something about. Why? This is not defined.
The answer was not based on an unhappy sign. What's that?
They have to be sad.
If unhappy snap.
I'm sad.
Amy, has it been a long day?
All right.
Don't kill it, don't kill it.
Get your calculator out.
It's just filled with too much.
What is it?
It's just
What
spider. Don't kill it. No, Brian.
No, Brian. I hope it's a front.
Do we need to make a big deal of this?
Yes.
Oh,
Nice. I don't know.
Yeah, he was.
Right, throw it out the
like,
window,
dangling
let's
by
move
his
on.
handle.
All right, over here. Guys, zip it. Okay. Log buttons are over here on the left side, right? This is nothing more than to make sure you know where the buttons are, in all honesty. So what was the number? Log of 0.908. Negative. Now, the other class was bothered that we got a negative. A log can be negative, right? Because we can have negative exponents. Yes, we can't plug a negative inside the log, right? Not log of a negative. Okay, so negative 0.042.
Is that irrational?
I don't know. I really don't know. 0. Negative 0.042. All right, and then the natural log of 7, that's just the button down here below it, which is 1.946. All right, I have a couple baby equations for you to solve here.
Can we?
Later this week, we'll do more complicated. But I bet you can do these both right now. Oh, okay. Right below the LO. Okay, number 1, 3 squared is x. So x is 9. Number 2, what's the base? 10 to the negative 4 equals x. So isn't that 1 over 10 to the 4th?
Yeah.
And powers of 10 are nice because that tells you how many zeros, right? How many zeros?
I wrote it in scientific notation.
Let's go for a fraction.
4 zeros.
4 zeros. So 1 over 1/10,000. All right, now we're ready to graph. So, guys, extra chatter doesn't need hassle. All right, when I wrote this down here, remember this whole business, green on green stuff? So doesn't that mean that anything in the log has to be strictly greater than 0? Okay, that is going to be what drives our domain here for all of our log functions. And some of you did this earlier this year, right? You analyzed this. Well, we all did, but some of you were in charge of it. So you're going to take whatever's in the log and set it greater than 0 for the domain. So you set x greater than 0. So therefore we have 0 to infinity. That 0 plays an important role because that gives us our VA. Okay. So which one of the windows are we looking at? Which one?
Said yellow.
So yellow is e to the x.
That one, the pink one, the red.
Maroon.
Pink is x squared.
Maroon. Blue.
The red.
It's red.
Whatever. Okay. So what was I getting at? Oh, that has a VA, right? Yes. And our exponential has an HA. So if they're inverses of each other, shouldn't they have like inverse things? So like this one always has an HA, that one always has a VA, etc. So that 0 that you found up here determines your VA. So your VA is at 0. You're
I
not.
just now noticed that you wrote the asymptotes for those.
I did.
It's so hard to see.
It was a lot of hot gluing and a tall ladder. not very safe at all, but it was worth it. It's totally worth it. Okay, so what I want you to think about is the fact that this is gonna have a VA but no HA. Okay? Looking at the red, what's the range? Done already? Okay, thank you. See you tomorrow. All right, are there any breaks in the graph?
No.
No, and don't be bothered by the fact that it does have an asymptote. That's not part of the domain, right? 0. So on its domain, it's continuous. What's its behavior like?
Increasing.
All the time. No symmetry, no boundedness, no extrema. Remember, boundedness is only up and down, not left to right. And then end behavior. Because it only exists to the right, you're only going to have right end behavior. So what is it doing as we move to the right? Increasing and going towards infinity. So limit x goes to infinity is infinity. Okay, how are we going to approach the graph? Here's our function. What's the base? E. Okay. So can I rewrite this as e to the f equals x? E to the f equals x.
Yeah.
So this is where we're gonna get crazy, right? You ready? No, normally we plug in x's to get y's, right? So now we're gonna plug in y's to get x. Just 3. Okay, so I just picked 3 easy ones. So we would have e to the negative first, right? I'm just going to write that as a fraction. What is that? 1 over e. What's e to the 0?
1.
And e to the first? E. And e is approximately what?
Mm-hmm.
2 point.
Why are we using 1 over e instead of negative? Oh, because we can't.
And then what would 1 over e equal?
0.368.
Yeah, so about a third-ish. Everybody okay? All right, so we're just gonna graph those 3 points with its asymptote and go from there. That's it.
Mm-hmm.
So
This is an easy lesson.
I'm glad you think so.
Do you?
Do I think so? Well, that's not really a fair question to ask your math teacher.
So you shouldn't take too long on your test then, right?
Right.
Since it's a breeze,
Yeah.
you should have your test done in the
Yes.
a lot of time. Huh,
Oh, what did I? Oh, that's right.
I'll remember that.
So in this, for these graphs today, I'm going to try to use more of the graph so it's not so smushed. So I'm going to go every 3 is 1, and then every.
I'm with you, buddy.
Same thing here. You don't have to do that, but it just makes it a little nicer to use the whole graph. So we have about 1/3 -1. And then 1, 0. And then we have about 2.7, 1. Alright. So the next two are just gonna be transformations of that. So the first one, we're gonna do transformations. Second one, I'll just show you. So with one here, what's happening to the natural log graph? Left two, x-axis, good. So we're gonna left two, x-axis reflection. Then let's state the domain range VA. So domain. So this is the first one that's gonna go away from our other domain. Yes, you need to set x plus 2 greater than 0. So x is now greater than -2. Now that should make sense, right? Because if we're moving the graph to the left too, its asymptote is changing, so its domain is changing and all that good stuff. So -2 to infinity. So based on that, what's the VA? And the range? All rails. Perfect. Okay, so take your graph.
I missed all of that. Domain, we just found like the domain range.
Yeah. All right, so what I'm going to do is I'm going to graph the asymptote -2.
Your graph appears to be like a different size than mine.
Yeah, I'm just scaling mine.
She went off.
You don't have to follow me. I'm just trying to use more of the graph.
I'm just saying, is it?
Okay, here was our first point, correct? Like the negative, the 1/3. So I need to move it to the left 2, correct? So left 2, and then I need to reflect it, so it would end up here. So it would be here, it would go here, and then reflect it. What?
How did you get those points?
So I'm using the previous graph.
Oh.
So take a look at that one, and then,
And then do like reflecting.
Yeah. and I'm just moving on. The next point was here. So left 2 would be here. And then if I reflect it, does that move? And then the third point was 2.72, no, 2.71. So left 2, and then reflected. Questions? All right, the next one we're just going to use our calculator, but first let's find the domain and stuff like that. So when I go to find the domain, I need to set -x greater than 0, right? Okay. So what's going to happen when I solve for x there? So x is now
Doesn't have to be. Just
I understood.
where's the VA? At 0, x equals 0. And range? Yeah, I like to get that info first, because now I know I'm only using the left part of the graph, yes? So I'm gonna put my y-axis all the way over there. My x-axis in the middle. And it's on my asymptote. And maybe just make a note. So here we use transformations. Here we're going to use our calc and the table. Just to show you different methods here. So go ahead and type that into Y1. So if you type it in, 2 natural log negative x plus 3. You're gonna see this nice stretched out graph here. And then whatever points you want to use, I'm just gonna use -3, -2, -1. I'm gonna scale my x's, but not my y's. So what was -3 was a little over 5, right?
Yeah.
And was -2 a little over 4?
Yeah.
And what was -1? 3. Okay, so we have something like that.
So what are those numbers again?
So I just picked a few negative x values in my table here, -3,
Oh,
-2,
okay.
and just plotted those. Any questions on that?
On the test, when we have to draw the asymptotes and they overlap with like the axes, can we just put like the x equals 0 or whatever to show, since we can't like put the dotted and the solid?
Yeah. And then as long as it doesn't touch, as long as your graph shows that it's approaching it. That's okay.
I just put a dotted line. I didn't put the y-axis.
Or that too, yeah. I like that. Either way. Yeah. All right. Here we're just gonna use a different base, but essentially it's gonna be the same thing. So base 2. Notice the x inside there makes the domain just greater than 0, right? So domain x greater than 0. So our VA is x equals 0. Range, all reals. Yeah. So you remember how so here's the fun fact. Do you remember how the domain of an exponential is all reals?
Yeah.
So then, since they switch for inverses, then the range is always all reals.
I like them.
Yeah. Oops. And then if you rewrite this, isn't that 2 to the g equals x? Yeah. So I'm gonna make you a little table here, g. So if we plug in, let's just do -101 again. You might recognize these, right? Because we're just taking 2 to powers, and that was last week's stuff. But we're just inverting it now. So 2 to the negative first is a half, 2 to the 0 is 1, 2 to the first is 2.
I heard something else.
What transformation happens to give me number 4? Just need to move right 2, yes? So all that's gonna do, I'm just gonna move points on this one, okay? I'm gonna move my asymptote to the right 2, and I'm gonna move my points to the right 2. So without doing the algebra, what will the domain change to? If I move this over, Nick,
You did a negative.
not 2 to, 2 to, yeah.
Yes.
Or infinity.
Yeah, 2 to infinity, right? So if I just move this over and this graph moves over, my domain is now 2 to infinity, yes? Okay. So domain 2 to infinity, dA, x equals 2, range all reals. So all I'm gonna do is move points to the right 2.
Or confirm. To confirm.
Okay, any questions on graphing? No. All right, you might be wondering, what in the world are logarithms used for? So eventually, in some science class, at some point, you should study sound intensity And you've probably heard the term decibels. So there's this equation that is used to figure out how many decibels are in a certain sound. So we're given the equation, beta equals that. This is the threshold of human hearing, the quietest sound you can hear. So we want to figure out a subway train. So a subway train has a sound intensity of this. So that's going to be called I. And I'm just going to plug both of those numbers in
Yes.
up top. 10 log. And then, so I is given in the problem to be 10 to the negative second. And I sub 0 is given to be 10 to the negative 12. And so it's just our job to simplify this without our calculators. We can do it. Okay. So I'm just go ahead and switcheroo those right there. Yeah. 10 to the 12 over 10 squared. So what does that simplify to? 10 to the 12th over 10 squared. Careful. Subtract.
Oh, 10 to 10.
Okay. Yeah, are you ready for tricks?
10.
Right?
Yeah.
What does this simplify to? 10. And this comes down. So, if you can imagine a subway train, that's about 100 decibels. Okay? Okay. We're gonna skip the 2 truths and a lie, even though it's fun. Go to 3, 4. I'll feel better about myself if I can at least do a couple of these. You know how much money goes into that? Okay. Here's what's going to happen tomorrow. So I'm gonna do like at least like one of each type with you right now real quick, okay? Tomorrow, bring your laptop, or at least one of you have your laptop for pod.
Yes.
The notes will be posted that you can fill in, okay? So, and then whatever time is left, because it shouldn't take you very long to do that, because it's just front back, right? Whatever time's left, you can work on your 3-3 and your 3-4 homework. All the answer keys are up here and online. Good deal? Okay. So, again, you have seen these before. It's not brand new. I'm going to kind of skip over a couple of things. I'm not going to do the proof. This, whoops. Do you remember log rules at all? So like, if you're multiplying logs, you can add. Which does that remind you of exponent rules? When you're multiplying, you add exponents. When you're dividing, what do you do with exponents? Crazy. It's like there's a connection that I can't get into right now. And then if you have a power to a power, right? If you have x squared cubed, don't you multiply? Aren't you multiplying here? And I always do this, like that comes out front. Okay, let's go to this first one here. Okay, we're expanding. So what separates the 5 and the x? Multiplication. So multiplication says you can do what to split it up? Add. Okay, so this will be log base 5 of 5 plus log base 5 of x. Then the only catch is, if anything simplifies, you better simplify it. So like log base 5 of 5 is 1. Couple ways you can look at it. You can go to your favorite trick and note that that's 5 and 5, and then it just goes to 1. Or you can think 5 to what power is 5? 1. Let's do 2. Would you agree there's 2 multiplications now? Okay, so I'd have natural log of 4 plus natural log of x plus natural log of 4.
That 4 being down.
Yes. And once you get good at these, in fact, you might be able to do it in one step. I'm totally fine with that, but I want you to take it slow. By the power rule, then that goes down. So if you can do that without these 2 steps, by all means, just do it. Okay, flip it over. Let's do one of the condensing ones. Okay, if you're going backwards then, subtraction, what are you able to do? What operation? Division. So this becomes log base 5 of x divided by y. Okay, I'm gonna let you look those tomorrow. And then change a base formula. Says you can rewrite a log using any base you want by doing log of that over log of that. So this right here, ready? I just like to use base 10. Stay with me. This can be rewritten as log of 7 over log of 4. But then, like number 3, stay with me, this is the last one. Or no, let's do this one. This one says using only natural logs, right? Which is ln. So you would do natural log of c minus d over natural log.
I know, but I was just telling you because I had to learn this whole lesson.
It's nice of you.
Okay, that was your 5-minute lesson on that. So, tomorrow, you still get everything done. Okay, so you were saying, are you both in the same study hall? No.